All right, guys. So now I'm going to go ahead and talk about how to find the surface area of a sphere. Now, when dealing with a sphere, there's no such thing as lateral area because a sphere has no actual base. It's just a ball, right? Just think about it. So you're not going to have to worry about, differentiating between lateral and surface. So that's the cool thing. Also, the cool thing about the total surface area of the sphere is that it's just 4 pi r squared. So there's only one variable you have to worry about, and that is r. So these are going to be very simple, very easy. Let's go ahead and look at an example here. Oh, and by the way, when you're gonna try to draw these out on your notebooks, for those of you guys that wanna, do them like that, I'm gonna show you really quick how to draw a sphere. So as you can tell, it all starts off with a circle. So you just draw your own little circle, and then you kind of draw an oval inside, but with a dashed line, and that's pretty much it. Like a little dotted line. All right, and there's your sphere. Okay, and I've seen some pictures where they come and they do another one over here just to give it an additional depth, right? But yeah, that's how you draw spheres, guys. Okay, more or less, more or less. I know it's not perfect, but anyways, let's go on to this problem right here. Remember, we're looking for surface area, and surface area is going to be 4 times pi times your radius squared. My radius is 14. That's all I need to know. So my answer will be 4 times pi times 14 squared. I come to my calculator and that's what I put. 4 times pi. Again, remember pi is 3.14 for those of you guys that do not have or cannot find the pi on your calculators. And my surface area in this case is 2,463.01. So I'm going to leave it like that. And again, units squared, whatever they are, units squared. I'm going to go ahead and give you an example now where we work backwards. What if I give you the surface area and now you have to find the radius? So if you knew that the surface area was 1,000, keeping in mind that the formula is, again, 4 pi r squared, and you had to find the radius, well, simply substitute. 1,000 must be equal to 4 pi r squared. And just do some algebra, guys. Okay, remember, on all of these guys, on all of these formulas for surface area and for volume, if you can substitute and you know your algebra, your inverse operations, you can find whatever they want. So right now they want us to leave r by itself. Again, on my calculator, it's just a matter of me saying that it is 1,000 divided by this 4 pi. Notice how I'm using parentheses to indicate this. I could have also, written it down in my calculator like this. And so I find out that r squared is 79.5. Now, if you didn't have the ability to do that, I've told you guys that you could just find out what 4 pi is. So 12.56, 664, so 57 r squared. So we would just divide, and notice how we're pretty much going to get the same thing. That's 79.57. So 1,000 divided by 12.57, 79.55 in this case. But again, the answer is so close. Even if I round it, pretty much get around the same ballpark. So now after division, I have that this is 79. I guess I'll go in between. I'll say it's 56 is equal to r squared. Okay, actually, I'm gonna make it an 8 because I have the calculator. I don't have a reason to be using other numbers. Anyways, to get rid of the r squared, we do a square root. All right, again, notice how we gotta know when to use the stuff. Very important. And so we find out that our radius is about 8.9. and that's it. Remember, I did the square root of this 79.58. That is how I got 8.9. Is that easy, guys? Now remember when we're talking about area and we started talking about the area of a sector, okay? Or even when we're doing arc length and we said it's just a fraction, right? So just like when we were doing an area of a sector and it was just a fraction of the entire area, there are things here that look like this. Now I'll be honest, when it comes to geometry, at least in my class, odds are you'll never see this in one of my problems in one of my exams. But you never know if you're going to see it later on in an ACT or SAT. So just heads up, right? It's not too crazy. All you need to do, guys, is simply derive it, right? So if you're told that, if you know that the surface area is 4 pi r squared, and we know that this is just a fraction. If you wanted to find this area, we're just going to do a quick alteration to the formula. So to find the area here of this, I guess part of the sphere, of the surface area, so we still use this 4 pi r squared, but we create a fraction where we're going to use theta as our angle and 360, right? Because there's 360 degrees in a circle, in a sphere. And that's pretty much it, guys. Okay, so again, odds are you'll never really get to see this, but this is how easy these problems are. Spheres, substitute, work backwards if you have to, but for the most part, just plug in and you're done.